Okay, for topic 4, we're going to go back to this idea of empirical probability. We discussed this in section 11.4. It's back. Okay. So I do want to specify we're going to be dealing with empirical probability for events involving not and or. Okay, so we've already talked about those not probabilities, like where we talked about the complement of E is not E, and then events involving or. What is the probability of this or that? But now we're going to be looking at kind of like maybe not real world data, because I'm sure this was real at some point. It's dated at this point, but allegedly real world data. Okay, now please do remember when we're dealing with probability, we kind of have two different categories. We have theoretical probability, which is what could or should happen when you have equally likely outcomes. And then we have empirical probability, which is what we observed. So we went out there, we collected data, whether this table is made up or actual is to not to be worried about. But we're going to assume this is real world data. Somebody went out there and they collected this data. Okay. And then we look at probabilities based on this actual observed data. Okay. So luckily, this table you have seen before. The table shows marital status of Americans age 15 and up. The numbers are in millions, okay? We have the table split male, female, and then the marital status that you could have is married, never married, divorced, or widowed. And remember, we talked about this in 11.4. Assume we're talking about the most current marital status. The day this information is collected, what is your current marital status at that point, okay? Yes, some of these could have happened more than once for somebody. In order to be divorced, at some point you had to be married. Okay. We're not saying you're married and then now you're divorced. We're just talking about now you're divorced. Forget everything prior to that. Now you're currently divorced and you've not remarried since. Okay. Same thing with widowed. Of course, to be a widow or a widower, you had to have been married prior, but we're just saying at this point you are widowed, you haven't remarried since. Okay. So again, with this table, assume we're talking about the most current, the day this information was collected, what was your marital status at that point? Okay. So with all of that said, find the probability rounded to the hundredths place. Okay, so two decimal places that a person is randomly selected, and for part A is married or female. So we want the probability of married or female. And so now we have to kind of get down to the point of, is this mutually exclusive, or I guess I shouldn't say is. Are these events mutually exclusive, or are these events not mutually exclusive? So remember, mutually exclusive is when they could never happen at the same time. And that doesn't make sense here because you can be female and married. There's overlap, okay? So in this case, we would say these events are not mutually exclusive. That means there is overlap. So when we do this, we would want the probability that you are married. I'm just going to do MAR for married, plus the probability that you are female, but there's definitely overlap. So we have to subtract. So I can't speak. I need to go home and take a nap so bad. We need to subtract the overlap. Okay. So let's see. What is the probability from this table that somebody is married? Well, the total for the married column is 133 million. Okay. So we want the probability of somebody being married is 133 million out of, remember, our grand total here is 254 million. Whoops. There we go. 254. We want to find the probability that somebody is female. So from this table, there are 131 million females, but there is overlap. We have people identifying as female and married. So that would be this right here. Okay. So we need to subtract the overlap because the overlap is being counted in the female row and the married column. Can't be counted twice. You can only be counted once. So what we have to do now is subtract off the overlap, the females that are also married. So that would be 67 million out of 254. Now, when it comes to your calculator, this is not going to be so bad. What I would tell you to do is 133 plus 131 minus 67 over 254. Okay, and then let the calculator do the simplifying. So let me show you this on a calculator really quick. All right, so I think it's easiest if you do the fraction template on these problems, this section and the section we do after this. So I would go alpha y equals, and the numerator, remember, let me remind myself of the numbers. Um, where's the table? There it is. Okay, so we had 133 married plus 131 female minus the overlap, those that are married and female, which was 67, and then all of that was over 254 million. And then just hit enter and it'll do the addition and the simplifying all at once for you. So we get 197 over 254. So this one doesn't reduce, okay? So 197 over 254, but remember the direction said write your answer as a decimal. So your calculator, if you have the graphing calculator like this, it can take an answer that is a decimal and turn it into a fraction. It can also take a fraction and turn it into a decimal. So I've got this fraction here, but I want it as a decimal. So all I have to do is go to the math button, and you see this section the second option. So we have the first section, the first menu, which is the math menu, and the second option is decimal. So what that does is it'll take a fraction and it'll convert it to a decimal. So we want to choose option 2. And then it's going to be like, are you sure? And you say, of course, I'm sure, and hit enter. And now we have our answer here. So we get 0.77559 is what I'm going to write down. So 0.77559, let's go to our worksheet really quick. We'll do the rounding once we get to the worksheet. So we ended up with 197 over 254, and we got 0.77559, blah, blah, blah. Well, the direction said round to the hundredth place, so 2 decimal places. That would be this second 7. To the right of that, we have a 5, which tells me to round up. That means the 7 becomes an 8, and then I chop everything after that off. So we would say this is approximately 0.78. So if I were to randomly select somebody from this table, the probability that they're married or female, 78% chance. Okay? Hold on. Let me get a sip. Oh dear, I need a refill. All right, part B. What is the probability that somebody is divorced or widowed? Remember, we're talking about your current marital status. Yes, of course, somebody could have been married and then divorced and then married again and their spouse passed away and they're currently a widow. We're not worried about what happened prior. We're only worried about today, right now. Okay, your most current marital status, you are either currently divorced or you are currently widowed. We're not talking about previous marriages. We're talking about today. So there's actually no overlap here. Now, if we're talking about multiple marriages and this marriage or your most recent marriage or your most current marital status and then previous marital status, yeah, there can be overlap. But in this case, remember, I said at the beginning, we're only interested in your most current marital status, okay? So in this case, these events are mutually exclusive. And remember, mutually exclusive means they can never happen at the same time. So there's no overlap. Mutually, I can't spell to save my life. Exclusive. Okay, so these are definitely mutually exclusive. Again, we're talking about current marital status. In this case, there's no overlap. So if we want the probability that somebody is divorced, I'm just going to do DIV, or widowed, WID. We want the probability that they are divorced plus the probability that they are widowed. Again, we're assuming current marital status only. You're not looking at anything in the past. Okay? So looking at this table, the number of divorced would be 26 million. The number of widowed would be 14 million. So we get 26 out of 254 plus 14 out of 254. And then let's see, 26 plus 14, we can do that in our head. 26 plus 14 is 40. So we get 40 out of 254. And if I wanted this as a decimal, which we do, we just take 40 and divide it by 254 on the calculator. And I get 0.15748, blah, blah, blah. We're rounding to the hundredths place, which is 2 decimal places. So in this case, we're looking at the 5. Directly to the right of that, we have a 7, which tells me to round up. The 5 becomes a 6, and I chop everything after that off. So I would get 0.16. So if I were to select somebody at random from this table, the probability that they're divorced or widowed is there's a 16% chance of that. Okay? Scooting right along, let's look at part C. Is divorced or male? So the probability that somebody is divorced or male, well, we have to ask ourselves, could these occur at the same time? Absolutely. There are currently divorcees that are, or not divorcees, but people that are divorced and male. Okay. So these are not mutually exclusive. So we would want the probability that they're divorced plus the probability that the person selected is male. But because you can be divorced and male, we can't count you in both pools here. You can't be counted in the divorce pool and the male pool, so we have to subtract the overlap. Okay? Now, looking at the table, if I scroll up just a little bit, the number of divorced is 26, the number of male is 123, and then divorced male is 11. So let's do that kind of slowly. Let's just do divorced for now. So divorced is 26 out of 254. Male is, I believe, 123 out of 254. But we need to subtract the overlap. So how many identify as male and divorced? Okay. So male and divorced is 11 million. That's this number right here. Okay. So 11 million out of 254. And again, you can just type all of this into your calculator and it will reduce it for you. Or in the event that we want it to be a decimal, we can approach this differently. So let's see how we want to do this one. Let's go to the calculator. Okay, so remember, let me get my numbers. We had 26 million divorced plus 123 million males minus 11 million that were both male and divorced. So that's 138 million total divided by 254. I'm trying to type with my left hand and it's not going well. 138 divided by 254. And as a decimal, we get 0.543307, blah, blah, blah. So 543307. Okay, so we did the work on the calculator. You can either type it into the fraction template and let it simplify it, or you can just piece it together. It doesn't matter. Show me your setup though. So we get 0.543307. We're rounding to the hundredths place. That's the 4. To the right of that, I have a 3, which tells me to round down. That means I leave the 4 alone and chop everything after that off. So we get 0.54. So if you randomly select somebody from this table, the probability that they're male or divorced, 54%. All right. Married or divorced. Now remember, we're talking about your current marital status. Of course, to be divorced, you had to have at some point been married, but we're not worried about what you were a month ago, 10 years ago. We're worried about what you were today. So you are either currently married or you are currently divorced. Okay. So these are mutually exclusive. Okay. So we want the probability of married or divorced. That's going to be the probability that you're married plus the probability that you are divorced. And let's see how many we have. If we scroll back up, whoa, what did I just do? Ah. All right, if we scroll back up, there are 133 million married. Oh no, what did it do? I just messed my table up, I think. There we go. There are 133 married. There are 26 divorced out of 254. So let's see what the math is. So we get 133 married out of 254. 26 divorced out of 254. So let's see, 133 plus 26 is going to be 159 out of 254. And then we want to convert this to a decimal. So if I do 159 divided by 254, I get 0.625984, blah, blah, blah. Okay, we're going to go to the hundredths place. So that's this 2 right here. To the right, I have a 5, which tells me to round up 2 becomes a 3, I chop everything after that off. So I get 0.63. So if I were to randomly select somebody from this table, the probability that they're married or divorced would be like 63% chance. And then finally, we've got 2 more. Part E, what is the probability that somebody is never married or male? You can have males that have never been married. So there is definitely overlap, which means these are not mutually exclusive. Remember, mutually exclusive means they can never happen at the same time. These 2 things could happen at the same time. So we want the probability that somebody was never married or male. So that means we want the probability that they were never married plus the probability that they are male. Okay, and we want to subtract overlap. We definitely have overlap here. Okay, so let's see. Never married is 81 million. Male is 123 million. And then we definitely have some overlap up here. We have 43 million that are never married and male. Okay, so let's see what this is going to look like. We get, doggone it, we got to change our pen. We get, let's see, what did I have? 81 million are never married out of 254. 123 million out of 254 are male, but there are some males that have never married, so they're being counted in both pools. We can't be counted in both pools. You got to you got to remove the overlap, okay? And the overlap was 43 million. Let me double check that 43. I think I have that right. Yeah, 43. Okay. So let's do a little figure in here. So let's first see what 81 plus 123 minus 43 is. That's 161. And when I divide that by 254, I get 0.633858. We're looking at this first 3 right here. To the right of that, I have another 3. Tells me to round down. So this one rounds to 0.64. And finally married. And finally, we have never married or divorced. Now, in order to be divorced, you had to at some point have been married. So we can't say you're never married and divorced. There's no overlap here. These are mutually exclusive. Let me scoot this picture that's in my screen. Mutually exclusive. Okay, so we want the probability of never married or divorced, which is the probability that you never married, plus the probability you're divorced. There's no overlap here. So never married was 81 million out of 254. Divorced, I want to say is 26, but I could be a liar, pants on fire. 26 million are divorced. So let's see, we get 81 plus 26 is 107 out of 254. Write that as a decimal. We divide by 254. I get 0.42125998, blah, blah, blah. We're looking at this first 2. To the right of that, I have a 1, which tells me to round down. So this would be approximately 0.42. Okay? So there you have it. Make sure when you're doing problems for me, you have to show me your setup. Okay? I know we can all just type a bunch of numbers into a calculator and get to this point. But unless you show me how you get to this point, you don't get credit. So I need to see this setup right here. I especially need to see this setup, but I would like to see it in words, then in numbers, and then see your final answer. Okay? So make sure you can show me your setup. No naked numbers. Plain old numbers indicate either cheating or cheating or cheating or laziness. Okay? So show your setup. All right? In the next video, we're going to talk about probability and odds.